Hi, how's it going? Welcome to Code with Z. In today's video, we gotta rotate this linked list that we have here. Why? Because that's what LeetCode 61 rotate list is asking us to do. As you can see, it says we're given a head of a linked list. So basically this that we have here, this one, and we gotta rotate the list to the right by k places. Alright, so this is gonna be our linked list and this is gonna be our k. For example, our k is 1, that means we have to rotate our linked list once. Well, first of all, let's see what that would even look like. Currently, 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 5. If we actually rotate this, 5 is gonna point to 1, and then we're gonna have the same thing, and our end is gonna become 4. So we're gonna basically have this. As you can see, 5 is pointing to 1, 5 is pointing to 1, 1 is pointing to 2, 1 is pointing to 2, and 2 is pointing to 3, 2 is pointing to 3, 3 is pointing to 4, 3 is pointing to 4, and 4 is pointing to nothing. Because we said if we actually rotate this, 4 is going to become the last node, and 5 is going to point to 1, meaning 5 is going to become the head of our node, like so. So if we actually want to do this, if we want to go from this to this, all we need to do is to follow two simple steps. First, if we name this the head, and if we name this the tail should point to head. The tail, which is 5, as you can see, 5 should point to head, which is 1. This is our rotated list, and if we actually do something to get to this result, that means we've actually done it correctly. So tail should point to head, like so. Tail should point to head, like so. Now the only thing that's remaining is to make 4 point to null or nothingness. So we basically have to get this, and we have to be like, no, you're not going to point to 5, you're just going to point to null, like so. And this is basically the same thing that we have here. 5 is pointing to 1, 5 is pointing to 1, 1 is pointing to 2, 1 is pointing to 2, 2 is pointing to 3, 2 is pointing to 3, and 4 is pointing to null, and 4 is pointing to null, like so. Let's have another example. Again, k is 1, meaning we only have to rotate this once. But even if k was 3, we're going to repeat this process 3 times. So it's going to be the same thing. So now our k is 1, so we have to rotate this once. So if we do that, we're going to get this, like so. 4 is pointing to 5, 5 is pointing to 1, 1 is pointing to 2, and 2 is pointing to 3. Currently, our 4 is our tail, and our 5 is our head. But in the rotated version, 4 is going to be the head, and the tail is going to be 3. So we're going to have the same thing. We're going to say tail should point to head, tail should point to head, and then this is going to be our first step, and then we need to make sure that this node here is going to point to nothing, because here 3 is pointing to null. So we're going to say get this one, and it should point to nothing, like so. And now we have the same answer that we have down here. So how did we actually find this position? Well, I'm glad you asked. I'll show you how we find this position in our last example, and then we're going to get to the code. Let's say we want to rotate this. In this example, we're going to have more details to see how we can actually find that position to make it point to null. So if we actually rotate this, we're going to get this for the same reasons that we saw in the previous slides. So let's see how we can actually get to that. First, we said we're going to define our head and tail. So this is going to be our head, and this is going to be our tail. Then we're going to say tail should point to head, right? So this is going to be the first step. When we do this, our tail and head are still going to be this, right? And we need to get to this position to make this point to null. So for doing this, we're going to have this simple formula. We're going to have a simple variable called count, and we're going to say this is equal to length, the length of our linked list, which is 5. Why? Because we have 1, 2, 3, 4, 5 nodes. So the length is going to be 5. So count is equal to length minus the result of k mod length, like so. So for example, our length is 5, right? And our k is 1. So 1 mod 5 is going to give us 1. So we're going to say 5 minus 1, that's going to give us 4. So let's bring this here, like so. Now we're going to use this count to get to this position. We're going to say we're going to loop through our linked list, and on each round of our loop, we're going to decrement count, and we're going to keep on looping as long as count is greater than 0. So for example, count is greater than 0, so we're going to say head is equal to head.next, like so, and we're going to say tail is equal to tail.next, like so, and then we're going to decrement count. So this was one round of our loop. Then we're going to have another round because count is currently greater than 0. So we're going to say head is equal to head.next and tail is equal to tail.next, like so, and we've decremented count. This is still greater than 0, so we're going to keep on going. Again, head is equal to head.next and tail is equal to tail.next, like so, and now count is 1, still greater than 0, so we're going to do it again. We're going to say head is equal to head.next and tail is equal to tail.next, like so, and now count is 0, and would you look at that, we're currently in the position that we want. So if we actually follow this logic, tail is going to end up at the position where we want to say this should actually point to null, like so. And if we check, this is going to be the same thing that we had in the beginning. We have correctly rotated our linked list. 3 is pointing to 4, 3 is pointing to 4, 4 is pointing to 5, 4 is pointing to 5, 5 is pointing to 1, 5 is pointing to 1, and 1 is pointing to 2, 1 is pointing to 2, and 2 is pointing to null, 2 is pointing to null, like so. Now, this is basically everything we need, so let's code this in the simplest way possible. Alrighty, so first of all, just like we saw on the slides, we need to define our head and tail. Our head is going to be pointing to the first node in our linked list, for example, this node that we have here, as you can see in the picture, and our tail is going to point to the last node in our linked list. For example, this one that you see in the picture. But if we check, we're not given the length of our linked list. That's still unknown. So let's define a variable called length, like so, and this is going to be equal to 1. We're going to assume that we have at least one node for starting, and then we're going to also define our tail variable, and this is going to be equal to head. So in the beginning, we're going to say tail is going to be pointing to the first one as well, and then we're going to say while tail.next exists, do the following. Here we're gonna loop through our linked list to get the length of it. So we're gonna basically say tail is equal to tail.next, and on each round we're gonna say length should be incremented, and this is basically gonna give us the length of our linked list. So now we know how long is our linked list. So let's follow our two simple steps. We said tail should point to head, right? So we're gonna say tail.next should point to head, just like we saw on the slides. And then we have to get our count. So we're gonna say let count be equal to length, just like we saw on the slides, minus k mod length, like so. And then below this, we're gonna say we wanna keep on looping. Let me scroll down a bit. We're gonna say we wanna keep on looping as long as count is greater than 0. Here we're gonna say head should be equal to head.next and tail should be equal to tail.next, like so. And on each round, we're gonna decrement count, just like we saw in the slides. When we're done with this loop that we have here, tail is gonna be at the position where we wanna cut the next one, and we wanna make the node that tail is pointing to point to null. So we're gonna say tail.next should point to null. Basically what we saw in the previous slides. And believe it or not, we're done. We only need to return the head, but here we assume that the length of our linked list is at least 1. But what will happen if we're given an empty linked list? Well, if that happens, we're gonna say if head is equal to null, return head, like so. Because if we have an empty linked list, we can't rotate anything, right? So we're just gonna return it. So now let's run it and see if we're gonna get accepted. I hope I've not made any typos. Awesome. As you can see, we passed both of the test cases. Now let's see if we're gonna pass all of them. And let's see. And awesome, we got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.